Okay, here's another example. They want to create a prayer meditation area outside their school, and they give the budget. They say here's the railing. You can have 18 meters of railing. They come in 1 meter sections that can't be cut, and you need to build a rectangular prayer area with the largest possible area. What are the dimensions of the prayer area? So I draw a quick sketch. So I've got some kind of rectangle with length and width. The area I don't know, but I want it to be a max. And the perimeter I know is 18 meters. So I know that there's a relationship between perimeter and length and width. Times the width. But just like in the other ones, I've got too many variables. I want width in terms of length, basically. Okay? So what I'm going to do is I'm going to take 2 length away from each side, because I'm going to do the same to both sides. So I'm going to minus both sides by 2 lengths. So I've got 18 minus 2 lengths equals 2 widths. I took 2 lengths from both sides. And now I want width on its own, so I can divide everybody by 2. So I'm going to divide everything by 2. I've got to divide each of these by 2 because they're separated by a plus or minus times. I got width because they're all one term. These are separate terms. So everybody gets divided by 2. So I've got 9 minus L equals width. Equal to 9 minus the length. So that's a formula for me I can use in my Excel spreadsheet now. So I'm going to grab my spreadsheet. And the lengths are going to go 1, 2, 3 as guesses, right? And just like we did before, we're going to zoom down to, I don't know, 20. And well, it couldn't be more than 20. It could only go to 18 at the maximum, couldn't it? Because we've only got 18, and that'd be 18 straight lengths, and it wouldn't make a rectangle, though. It would just be a straight line, but that's okay. All right, so the widths we know is going to be equal to 9 minus the length, whatever the length is. And let's make sure this makes sense then, okay? So, and we'll zoom this down. Let's see if any of these numbers make any sense. So if the width was 8, the length was 1, then let's look at our diagram. The width is 8 and the length is 1. Let me get that guy back up there. Then our diagram said the width is 8 and the length is 1 would be 1 plus 1 is 2, that's the 2 lengths, plus 8 plus 8 is 16, so 16 and 2 is 18. Does that make sense? Going around there, 2 2s and 2 7s makes 18. 7 plus 7 is 14, plus 2 is 16, plus 2 is 18. The perimeter is always going to be 18. In fact, we can double check it here, because we should say equals 2 times whatever the length is, plus 2 times whatever the width is, and that better be 18 every time, because that's what we said, that's all the wood we have. And then we're going to go to area, equals whatever the length is, times whatever the width is, right? And we're going to see how big of the area can be. Zoom. Now something weird going on here. I got some negatives. I couldn't have a length of 10 and a width of -1, so I think I'm just going to delete all these guys. Delete. Okay. So which is going to give me the biggest area? Here we go. In fact, there's 2. It could be 4 by 5 or 5 by 4. It really doesn't make a difference, does it? 4 by 5 or 5 by 4, it's just rotated. So there's going to be the biggest areas when the length is 4 and the width is 5, or the length is 5 and the width is 4. Basically a 5 by 4 rectangle. Which happens to what they gave for your answer. Although I don't really like that they only chose a few numbers, and they only choose a few numbers here for the width. That's why I like the spreadsheet, and I can do as many as I want. It would also said here in this one, in the examples, what if you could cut the railing and have the square to improve your prayer space, alright? So we could have 4.9, 4.8, 4.7, 4.6. So let's go ahead and do that. We could actually change our stuff, and because we already started with a spreadsheet, we can go ahead and do it in decimal 1 all the way through. So I'm going to bring the spreadsheet back up again. And instead of being 1, 2, 3, 4, 5, I'm going to say this is 1.1. The next one's 1.2. The next one's 1.3. And I'm just going to have that zoom and count all the way through. And everything else is just going to change because I kept those formulas already. So there's 1.1 to 1. Oops. Get there. Let's go all the way up to, it's going to go at least to 4. So I'm going to go all the way up to, well, let's go up to 5.5, 6. That'll be work. 6, that's good enough. Let's make this a little bigger so we can see. And do the same thing for this guy. It's the same formula, so I can just zoom him down. And same for this guy. Well, the perimeter should be 18. Let's double check that we did our math right. It should be 18 all the way through if we did it right. Yep. And the area should be length times width all the way through, so I'm going to zoom him down. Again, we're looking for the biggest area. So we knew it was around 4 and 5. That gave us the area of 20, or 5 by 4 gave us the area of 20. But now we're in this whole range here that we've zoomed in a little bit closer. If we could cut the thing, where's the biggest one? 20.25 looks like the biggest one right there. 20.25 is going to give us, let's change that color to give us the biggest maximum. It's not a lot of difference though, but if we wanted to cut them 4.5 by 4.5, oh look, it's a square again for the biggest area and the smallest, or the smallest perimeter. All right.